Okay, see Lindelof videos verifying a trig identity number 53. For verifying this trig identity, I'm going to do something I don't normally do. I'm not gonna manipulate this side, but I do need to rewrite it because I want you to be able to see it. So if you were to square this, remember this is called a LHS, a left-hand side proof, and you're not supposed to manipulate the right-hand side. All I want to do is show you what it equals. So secant theta minus tan theta, this whole thing squared would equal secant squared theta minus 2 secant theta tan theta plus tan squared theta. So this is not my manipulation. This is just me showing you that I have this, and I've actually done it in highlighter because I want you to realize that this is not how this works. My intention is not to turn this side into this one, but just to expand this to open it so you can see that what I'm saying is true. Now I'm going to try to do this off the top of my head. So what I'm going to do here is I'm going to multiply by the conjugate of the denominator, which is not 1 plus sine theta, but 1 minus sine theta, therefore the conjugate, over 1 minus sine theta. Of course, I'm just multiplying by 1. When I multiply these, I get 1 minus 2 sine thetas, right? Minus 2 sine theta plus sine squared theta. And when I multiply this at the bottom, I have difference of squares, so I have 1 minus sine squared theta, and is equal to, and I'm saying that this, and it's true, is equal to that, so this is secant theta minus tan theta, whole thing squared. My proof lies in this. So now what I'm going to do is this. What I'm going to do now is I'm going to claim a Pythagorean identity, and we do have a Pythagorean identity here, and I'm going to claim this Pythagorean identity right here. And I'm going to call this, from my professor, I'm going to say that this is a Pythag ID, and you need to be able to defend that. So there's my Pythag ID. I'm going to rewrite everything just the way it was, except for I'm going to put in my Pythagorean identity. I'm going to have 1 minus 2 sine theta plus sine squared theta over, and this is where I'm going to use my Pythagorean identity, 1 minus sine squared theta, we know from our Pythagorean identities, is cosine squared theta, is equal to this thing on the right, which I have already defended to you can be expanded, and I'm going to defend its expanded form. So look at this for a second. I have 1 over, I'm just taking this apart, 1 over cosine squared theta minus this minus sine is this one, 2 sine theta over cosine squared theta, right? Plus sine squared theta over cosine squared theta. Right, so we open this thing up, and just stop for a second to rewrite this, to remind you that when we took secant theta minus tan theta, the whole quantity squared, we got this mess, didn't we? So what is, we're kind of done here, what is secant squared theta but this? This is secant squared theta. 2 sine theta over cosine squared theta is this. And of course, sine squared theta over cosine squared theta is tan squared theta. So we have our proof. All right? I hope this is really helpful. Stuff gets a little bit difficult, so keep working on it. If you have any questions or comments, let me know. If you haven't already subscribed, please do. Thanks.